This is Activity 1, Matching Hangers, from Lesson 3, Balanced Moves, and Unit 4, Linear Equations and Linear Systems. And this is a revised version of Activity 1. In this activity, you're supposed to simplify hanger A to get to hanger D. So there are 3 steps. Simplify A to B, B to C, and C to D. And simplify means to remove all of the shapes that you can, keeping the hangers balanced, and ending up with the least number of shapes possible based on this beginning balanced hanger. After that, you're supposed to write the equation for each of these balanced hangers. And as an example, the equation for D is going to be a very short equation. It's just 2 triangles equals 1 square, whereas the equation for A is going to be a much more complicated equation with many more terms. Hence, we end up simplifying the equation and solving for what a square equals. You are given these 4 equations to match to the 4 balanced hangers. So the name of this activity is Matching Hangers. And you can see that the very simplest equation, 2y equals x, is going to match to the very simplest balanced hanger, which was the 2 triangles equals 1 square. But we're going to start with the most complicated equation, the most number of terms, and simplify this going through the steps to get to this simplest equation. I'm going to start with this very simplest hanger D and work backwards. So I'm going to add some shapes to D to get to hanger C, and then take those same shapes away to show you how to simplify C to get to D. So the equation for D is 2 triangles equals 1 square, or 2 triangles equals S. So if we go to C, here's D within C, so 1 square and 2 triangles. So if we take away a square from each side, so we're taking away an equal weight, so the hanger remains balanced. And if we take away a triangle from each side, again, taking away an equal amount of weight, so the hanger remains balanced, and we're left with D, 2 triangles equals 1 square. So if we look at the equation for C, we have this expression on the left, 3 triangles plus 1 square, which matches this left side of the hanger. And we have this expression on the right, 1 triangle plus 2 squares, which matches the right side of the hanger. And if we get rid of a square on each side, so get rid of this square, and this becomes 1 square, and get rid of a triangle on each side, get rid of this t, and this becomes 2t on this side, we are left with this equation, 2 triangles, or 2t equals S, or a square. So now if we look at B going to C, you can see that there are 2 of these groups on the left side of B. So this is one group of 3 triangles plus a square, and a second group of 3 triangles plus a square. You can also see that there are 2 of these groups in B. So here are 2 squares and 1 triangle, a triangle plus 2 squares. And there's 2 of those. You have to look a little bit harder to see it, but it's right here, 2 squares, 1 triangle, and 2 squares, and 1 triangle. But more than likely, you're going to see this as 4 squares and 2 triangles. So 4 squares and 2 triangles. So to go from B to C, you can remove one of these groups, and that's half of the weight for the left side of B. So now you're going to remove half the weight for the right side of B. And you can choose to remove one of these groups, the 2 squares plus a triangle, or more than likely you're going to choose to remove half of the 4 squares. So half of the 4 squares is 2 squares, and half of the 2 triangles. So half of the 2 triangles is 1 triangle. So you end up with one of these groups either way. So the equation for C is 3 triangles plus 1 square. That's one of the 2 groups, and a triangle plus 2 squares, and that's half of each of these terms. So this is called the term 2t plus 4s. This is called another term. So if I take half the weight away from the left side of the equation, I have to take half of each of these terms to keep the hanger or the equation balanced. So now to go from A to B, this is similar to the previous pair of hangers where we looked at B and C. So there's 2 of these groups, 3 triangles plus 1 square. So 3 triangles plus 1 square, 3 triangles plus 1 square. This is back to B again. And then on the right side are the 2 triangles plus 4 squares, 2 triangles plus 4 squares, 2 triangles plus 4 squares. But in addition, A has two circles on each side. So it's a balanced weight that's going on each side. So the hanger and the equation both remain balanced. So plus 2 circles, plus 2 circles. So now to go from A to B, we're going to remove these 2 circles. So now I'm going to work forwards, just going through the entire simplification of hanger A to get to hanger D. I'm going to remove 2 circles from each side. So now I have hanger B, and then from hanger B, I'm going to remove half the weight on the left side, which is 1 square plus 3 triangles, and half the weight on the right side. And more than likely, I'm going to look at half of this term, half the 2 triangles, and half of this term, half of the 4 squares, because that's the way the authors drew this. If they had moved this triangle up with these 2 squares, then I would remove one of these 2 groups. But they actually have drawn it to look like 2 triangles plus 4 squares. So remove half of each of those terms. You end up with C. And to go from C to D, you're going to remove an equal weight from each side of the hanger. So 1 square from each side, 1 triangle from each side, and you end up with D. And you end up with this equation in the end. 1 square is equal to 2 triangles. So here are the 4 equations once again. And I mentioned earlier that you can see that the very simplest equation is going to match the simplest balanced hanger. And the most complicated equation, the equation with the most number of terms, is going to match the most complicated hanger, which is hanger A. And this simplest equation is going to match hanger D. Then you just have to figure out B and C. So this is going to be B or C, and this is going to be B or C. And you can see that this is one of these 2 groups. You have 2 groups of x plus 3y, and here you have just one of them. And you can see that this is half of this term. You have 4 x's. This has 2 x's. And this is half of this term. This has 2 y's, and this has 1 y. So you can begin to put this together. This is A, this is B, this is C, and this is D. So here are all the hangers and all of the equations that go with those hangers. And you don't really need to use the provided equations. You can see what they're going to be. You just have to figure out which symbol, circles, triangles, squares, go with which letter, X, Y, and Z. So this is the equation for hanger A, and this is the equation for hanger A. So if you look at it long enough, you can see that this has 2 Z's, and there are 2 Z's here, so the circles have to match Z. And there's 1 square and 3 triangles in a group. So 1 square and 3 triangles, and there's 2 of those groups. So 2 of these groups. So this square has to match an X, and this triangle has to match the Y. So X is equal to a square, Y is equal to a triangle, and Z is equal to a circle. So now we can go through simplifying equation A to get to equation D as if we didn't even have these hangers to look at anymore. So to go from A to B, I'm going to remove 2Z. So here's 2Z right here, and here's 2Z right here. So you're going to get rid of those 2Z's by adding a negative 2Z. So positive 2Z plus a negative 2Z equals 0, so the Z's disappear. And so now we're going to get rid of half of the expression on the left. So it's going to be one of these x plus 3y's. So here it is right here, x plus 3y, and half of each of these terms. So on the left side, we're multiplying by 1/2 to get one of those terms. That's the multiplicative inverse of 2. And so on the right side, you have to multiply each term by 1/2. So 1/2 of 4 is 2, and 1/2 of 2 is 1. So you end up with x plus 3y equals 2x plus y. So finally, add a negative y to the right side. So y plus a negative y is 0, so this y disappears. And a 3 plus a negative y is 2y. And add a negative x to each side. So a negative x plus a positive x is 0, so this x disappears. And a negative x plus 2x is 1x. So this becomes 2y equals x, or is x equal, or x is equal to 2y. Simplifying the equation, going from A to D by making balanced moves.